Hello, my name is Abel Duprat, and I am an undergraduate research assistant at Northern Arizona University. Today, we're going to create and configure a fitting job to run on PyBioNetFit. PyBioNetFit is a software package that supports parameterization of biological models that is being developed at Northern Arizona University and Los Alamos National Laboratory. Documentation about this software is provided below. First, we will need to create a new folder for our job. And so I am going to open my File Explorer. And in my File Explorer, I'm going to go to my user profile. And I'm going to create a new folder in my user profile for my new job. I will do that by right-clicking and going to New and selecting Folder. And then I am just going to title this folder Config Job. Once I've named the folder, I will now open my folder, and I am going to input the files from my job. You will notice that there are three different file types here: the bngl, the config, and the exp file. These files, how to make these files is by creating a text document, and you can create a new text document by right-clicking and going back to New and selecting Text Document. And if you notice, the file type now shows as text document. But if you need it to be another file type, if you change the extension, that is the portion after the period at the end, to the file type that you would like to create, it will switch the file type to the appropriate one. So I'm going to add bngl and select Enter. And this is warning us that changing the file type may corrupt a file or change how it works. We are aware of this, so we're just going to hit Yes. And now we can see my text document has been changed to a bngl file. First, we will take a look at my bngl file, and we'll go over the changes that will need to be made in order for it to run on PyBioNetFit. So here I have my ground bngl. And as you can see, there are different blocks and sections of this file. So I'm going to go over these here with you and then go over which blocks will need to have edits made to them. So first we have the parameters. The parameters are used to provide numerical values for variables. They may appear in the species and reactions rule block. But after the parameter name, as you can see here, is a numerical value for that parameter. So for PyBioNetFit, we will need to take off the value, and then we will need to add it with the value underscore underscore free. And so this is what that looks like there. So I'm going to remove the numerical value, and then I'm going to type in the parameter underscore underscore capital free. And I am going to do that for this one as well. The reasoning behind this is that the parameter name that we had set is equal to a numeric value. So PyBioNetFit is going to assign a value to that parameter name. So now that we have it set as the underscore free, that will assign a value for this new parameter block set, where PyBioNetFit can now generate values for the parameter. Now on the bottom, we have the actions block. this is the next section that we'll need to make a change on in order for this to run on PyBioNetFit. And so the actions block is where we pick our methods for generating and simulating the network. And the change that we need to make is within the curly brackets here, we need to add a suffix, which I will do just by typing suffix equals greater than. And in parentheses, you will need to type in the name of your EXP file. I'm going to do parentheses. And then a comma to keep each one of those separate. And so now you can see that I've added, just towards the beginning here, my suffix line. And once again, that is the name of your EXP file in parentheses. Once these are done, we can go to File in the top left corner and Save. And you will want to save your bngl file with the changes made here. Okay. So now let's close this out. Okay, so let's take a look at the EXP file. The EXP file contains your quantitative data. There are no specific changes that need to be made to the EXP file in order to run in PyBioNetFit, but I do want to show you what it looks like. So on the first row, this contains a # followed by time, and then your observables from your bngl file. And so those are separated by a space or a tab. So as you can see, the only observable from my bngl file was the X open close parenthesis. So that is the only additional thing I have there. Going down each column, I have mine set where the time is going from 0 to 10. And then I have a set of data that I've marked that I've observed for that observable. So those are all indicated here in my EXP file. So that is all that is here. Like I said, no changes have to be made specifically to run on PyBioNetFit, but I did want to show you what that looked like. So I will close that. Last, we will talk about our configuration file. So the configuration file has to be edited in order to match the information from our bngl file. And then there are also separate blocks in that file, a directory output, the model algorithms that will be used, parameters that all have to be defined in here as well. So let me open my configuration file to show you what I have here. So towards the top, I have my directory. The directory output is where you would like your results to be stored after running the job. Below that, we have our model specification. So here I have my model, and what it is it equals my bngl file, and then I have a colon, and then my exp file. And if you had multiple data files, you can enter multiple data files here and such. But as we saw, I just have my bngl and my data file. Down here, we will define our algorithm and the objective function choice. So for my algorithm, I have mine set as SS, which is scatter search. The configuration keys that shows how those are defined are in the documentation below. For my objective function, I am running a sum of squares. And so this is the algorithm and objective function that will be used when the job is running. Down here, we have our parameters. These parameters need to match the parameters that we edited in our bngl file. It will begin with mine begins with the configuration key for uniform variance. There are different configuration keys, and there is a list of them in the documentation, different keys depending on what specific changes you would like to make. For this example, we're using the uniform variance. And how this works is there are 3 steps. There is the variable that comes from our bngl file, and it's the variable with the free parameter set to it. Next to that, we have the lower and upper limits that are set by our bngl file. So back in my simulation command, I was maxed out at 10. So I am running from 0, a lower limit of 0, to a higher limit of 10. And below this, we have the differential evolution parameters. And so here we define the population size and the maximum iterations that will run. And so I have my population size set to 20, and we are going to run 30 iterations total. So as long as you have all of these set up, once again, the change that would have to be made in order to run on PyBioNetFit is your parameters have to have the free indication followed by the minimum and maximum bonds set. Once you've made these changes, once again, in the top left corner, you can go to File, and Save. So let's close this one out. Now that all of our files have been configured to be able to run on PyBioNetFit, we can now try to run our job. So the first thing I am going to do is I'm going to copy the address for the folder that contains all of the files for my job. So towards the top here, I'm going to right-click on the name of my folder, and I'm going to copy the address. Now, to run PyBioNetFit, we will need to open the Anaconda 3. This we installed in our last video. If you do not have it installed on your computer, there is a link provided below to install it, because it will be needed in order to run PyBioNetFit. So let me go to my Start menu, and I'm going to open my Anaconda 3 folder, and I'm going to open my Anaconda prompt. Now on this prompt, I am going to type on the first line, cd space, and then I'm going to paste the address for my folder, and I'm going to do that by doing Control V. Once that is pasted, you will want to press Enter, and a second line should open. And on this line, you will want to type in PYBNF space -C space. Here you'll need to type in the name of your configuration file. So mine was once you have your line typed out like this, PYBNF space -C space the name of your configuration file, you can press Enter. And so this process the time that this process will take will vary depending on the parameters that you have set up. Since this will probably take about 20 minutes on my end, I am just going to jump to the end where it is finished, and we'll pick up from there. Okay, now that our job is finished running, we can see that we have completed the fitting job. And so now we can see our result now. Okay. Now that our job is finished running, we can see the results by going to the output folder indicated in our configuration file. So I am going to exit out of here by typing in exit and pressing Enter. So I'm going back into the folder of my job. And if you'll notice, we now have an output folder that has been created. And within this output folder, we'll have the results of the job. So I'm going to open that. I'm going to go into results. And you are looking for the bngl file. So I'm going to open that just so we can take a peek So if you notice here now, this is a copy of the bngl file, but under parameters, now it shows the value that PyBioNetFit has indicated is the closest fit for what we were working with. So we will notate these here. So I just wanted to show you that's what is being generated and saved into that output folder. So I will close that. Now that we have the results from our job, we can input those results into a secondary external simulator. The one I am using is RuleBender. If you do not have an external simulator, I have provided a link for that below. But the first thing I'm going to do is I'm going to copy our results bngl file, and I will do that by right-clicking and then going to copy, and I will open RuleBender. Once RuleBender is open, in the top left corner, we will go to File, and we'll go to New. We are going to create a new project. So as long as project is highlighted, we can select Next, and now we will name our project. Once you have a name for your project folder, you will select Finish. Now that my project folder is on the left side here, I will right-click on it, and I will paste. So I will paste the results bngl into that folder. And I can see it there. So now on the right side, I'm clicking on Simulation, and I want to make sure to click on my file so that it shows up here as well. Once I verify that they match, I will click Run so that a graph can be generated. And it will plot the points that it has from the results file and generate a graph for us, showing us what that would look like. And so to recap, we have made changes to the parameters and action block of our bngl file, as well as the parameters block of our configuration file. We have made those changes so that those files can be ran on PyBioNetFit. We have then run a fitting job on PyBioNetFit, and we were able to view the results via a secondary external simulator. In this case, I was using RuleBender. So now you know how to run a configuration fitting job on PyBioNetFit. Once again, this is Abel Duprat from Northern Arizona University. So long.